When you walk through an automatic door, you have witnessed one important application of physics known as the photoelectric effect. The motion sensor on the door contains what is known as a photocell. We discussed this in the lesson on the photoelectric effect, but let's play that process again in slow motion. In the photocell, electromagnetic radiation, mostly ultraviolet light, hits a metal sheet and leads to the emission of electrons from the emitter plate, which is known as the cathode. The emitted electrons hit the anode, which is the collector plate, and current now flows through the circuit. Now, let us hit the reverse button. What if we switch the polarity by turning the battery terminals and instead emitting electrons from one plate to the other plate? This time, we would also get some electromagnetic radiation from the other end. What type of radiation? X-rays. So in this lesson, we will learn about how X-rays are produced. Now let us add more detail to our basic explanation of how X-rays are produced. First, how are the electrons emitted? In the photocell, electrons are emitted due to the photoelectric effect. In X-ray machines, the electrons are emitted due to the thermionic effect. So let us add a heating element to our circuit here. Preferably the emitter, which is our cathode, should be a tungsten filament because it can withstand high temperatures without melting. Then we will add a curved plate behind our emitter to get a good focus of the electrons on the collector. Next is the collector side. The target plate is made of tungsten or titanium, but this is also embedded in a copper block to also serve as the anode. Copper has a high conductivity, so this helps to direct the heat and current better. Let's look closely at the tube before we move on. Remember that electrons are negatively charged, so they will leave the cathode and naturally be drawn to the positively charged anode, which is the collector plate. Raising the heat in the cathode will increase the number of electrons emitted, while increasing the potential difference will increase the difference in charge. This will make the attraction of electrons much stronger, and thus the electrons will move with very high speeds to the collector. So picture the electron like a bullet heading towards a wall. As the bullet collides with the wall, its energy is transferred to the wall, and this conversion of kinetic energy is accompanied by heat and sound. In the X-ray tube, the electron collides with the material, and over 99% of its kinetic energy is transferred to heat, and the rest is converted to X-rays. Everything here will get really hot after some time, so let us add some cooling fins here. So to get a faster rate of production of electrons, which will lead to more X-rays, we will need a greater current and heat. Therefore, we need a high voltage source, often greater than 100 kilovolts. And finally, we'll wrap this whole thing in a material like lead and leave an opening only where we need the X-rays to come through. And that is how X-rays are produced.